Now, excuse me, my name is Atul Roy. Excuse me. So I'm Atul Roy, all right, and I'm your sub for today, all right. So any questions for me? Anybody? Any questions that you have from previous homework or about anything in calculus that I can try to answer? Anything? Huh? You guys are good? I know you got a great teacher, so you must be good. All right? Okay. So we will just go ahead and go with the agenda that he gave me to follow. All right? So let me see. Very kind of you. You just keep this one. Very nice. Yeah, that works. Okay. So, all right. So as I said, I am Atul Roy. Okay. Okay, excuse me. And your sub today. All right. So again, I generally do this, that I don't write on the board, and I'll send the transcript of our conversation today to Dr. Nicholson, all right? And, or you can write me an email, okay? All right, and my email can be found at, it's very easy, atul.roy at, you know where, right? Okay, everybody clear? All right. .edu. And I'm doing something, trying to do something for the first time. I never did this much before. Okay, today I thought that let me try to record the whole lecture, all right? And put that on YouTube for you so that if you don't find the notes and you are interested still, you know, you can see. Would that work? Yeah, so see, we are recording the lecture, all right? Everybody heard me? So don't say anything strange, okay? This got pretty good microphone, okay? All right? So, because you don't want, I'm okay. My listening comprehension of modern English is not good, okay? But he might catch it, all right? Okay. Everybody fine so far? Okay. So I'm just thinking if maybe, okay? And in the case, in the event you would like to, so first, so what did he ask us to do? This is, oops, okay, all right, that's not a very good thing in the first one, okay. So here, so this is what he wants us to do today, okay? And as I said, write me an email, okay? And I shall send you a copy of all these slides that we are creating, okay? All right. So everybody fine that we have, derivative gives you rate of change, right? Everybody knows that, okay? And one of the things that you used to like find by using derivatives is what? A speed of velocity, right? Or rate of change. So that is basically what he wants us to do today, okay? That is do the work on the related rates. So what are the related rates? When we can relate the rates of change of two quantities, okay? And in this case, since we are going to see mostly or talk about mostly speed, okay? So you know, that's what we would do, and we shall start with an example. And in case you want to access any of my videos, okay, they will go like this, okay. Okay, so just access that website and you will see a bunch of them, okay. And I will see if there is no technical malfunction, I shall post our meeting of today also on this site, because now they have given me, okay, So here, because they have now given me permission to upload like longer videos, okay? So here you can watch related rates or whatever that I post for my online classes, okay? So anyway, coming back to our thing. Everybody fine so far? And as I said, first of all, avoid talking in the class because I get distracted. But if you want to keep it low and not non-disruptive, you don't have to force yourself to listen to me. But this microphone is recording everything that we are doing here, all right? So it's up to you, okay? Everybody fine? Okay, so I'll have to do this here. Let me go on saving everything that we are doing here. Okay, this is this, subbing, and today is what, March? What's the date today? March 21st. 21st, thank you. Okay, so, great. So everything fine so far? All right. So, okay, all right. Okay. So, excuse me. So this is, okay, and I'm going to, if I find two people talking and you don't listen to me, I'll just say on the microphone that so and so, would you please not talk? Okay, that's all right, because I told you I get distracted when too many people talk, but that's okay. All right, everybody fine on this? So this is the first thing that he wants us to do, all right? So, what is the question here? Would somebody read it for us, please? Anybody? Go ahead. Okay. Kareem, would you read it or? Yes, what? Air is being
pumped into a balloon so that its volume is increasing at the rate of 100 cubic centimeters per second.
Right.
How fast is the radius of the balloon increasing when the diameter
is
50 centimeters?
Thanks a lot. Okay. Everybody fine? So what's going on here? I mean, let me make a spherical balloon for you. Okay. So here is a spherical balloon. All right. Everybody fine? And what do we know? That they are pumping air in this at this particular rate, right? It could be anything like, we know how volume is changing then, right? Everybody clear on this? Okay. So, and then we have to do this, that we have to find the rate of change of a radius or the radius. I'm calling it a radius, that's okay, you know what it means. Okay. When the diameter is what? 50 centimeters. Everybody clear on this far, right? Makes sense? Okay. So what we got here is this. So we will do what? As we just saw in the professor's instructions, that we would just relate what? Relate the volume with the radius, okay? All right. And this is between you and the professor. I don't want to intervene. Is that, do you know what the volume of a sphere is in terms of its radius? Somebody, anybody? 4 pi over 3 times what? R cubed. Very good, very nice. So R cubed here. We got that there, right? Everybody fine? Okay. So that means he doesn't let you use, give you these formulas. He wants you to know these, right? Okay. Now, what do we know? We know that the rate at which the radius is changing, the volume is changing is what? What was that? I forgot. 100 centimeters, 100 cubic centimeters per second, right? Okay, so we know that dV dt actually looks like it's a uniform rate of change. So it's what? 100 cubic centimeters per second, right? Okay, good. So what we have to do then is to find, okay, dr dt, all right, when now that one he wants at a particular instant, all right, and what is that instant? And when the diameter is 50 centimeters, right? Now when the diameter is 50 centimeters, how much is the radius? Somebody, anybody? 25. Do you want me to explain why the radius is 25 when the diameter is 50? Okay, I won't, but that's okay. I mean, all right, good. So we know who the dV dt is, right? The rate of change with which the volume is changing, and we have to find dr dt, right? So all we got to do is what? Just relate the two rates of changes with each other, right? Okay, so tell me, what would we do? What would we do? Yeah, say that once again. Take the derivative, so differentiate. And with respect to which variable we want to do that? With respect to t, right? Am I clear? Good. Okay, so when you do that, on the left-hand side, we simply have who? dV dt. Everybody fine? And on the right-hand side, 4 pi over 3 is a constant, so we're just going to leave it alone. Or even if you use the product rule, you'll still get the same thing. And well, let me write all these steps because you're not that used to me, right? Okay, good. Everybody good? Okay. So if I go to the next step, all right. Okay, then Bill, if you told me your correct name, Bill, all right, could you tell me who is that? dr, d over dt of r cube. Am I talking to Bill there in front of Fernando, or Bill, could you help me, or anybody? Fernando, you can help me, or Elfie can help me. Anybody help me? 3r squared, right? We are using what? We are using what is called the chain rule, right? Okay. And then we got what? dr dt, right? Okay, so we have dr dt, right? Okay, good. So when we got all that, okay, what do they want us to figure out? We know this one is constant, right? Okay, so here is 100, right? And then these threes will cancel. Would everybody accept it, or you want me to show it cancel? Think they cancel, right? Everybody good? And then we got what? R square, and then simply dr dt. Very good. Yeah, I'm so encouraged with your participations. Very nice. Okay. So in other words, I mean, we related dv over dt with this, but since dv over dt is not variable in this case, we can just leave it like this. So what dr dt will be if we just divide by 4 pi r square, 4 when it cancels that 100, changes it to 25, right? Okay, and correct me because I'm just depending on so many smart people watching me do this, okay? All right, did I do everything correct? Okay, good. So at what instant do they want me to obtain dr dt? What was the instant? When r equals 25. Very nice, okay? So what that will be? Okay, that will be, yes, 25, then 25 here, right? Okay, and it's just 1 over 25 pi after we did the cancellations, right? Makes sense? And we have to write this also, what? The units, because otherwise, it doesn't mean much, right? Everybody clear? Did it make sense? Okay. So, good. So we have all this here, right? Okay. So look at it again and let me know if there is anything in here which is not clear to you. All right, everything good? Makes sense? And as I said, if you wanted a transcript of these, I can just write me an email and I'll send it to you right over. Everything good so far? Good. Okay, so now since we did this, all right, what I will do for the next one is this, that I'm going to just project it on the board, all right, and we will do it together, okay? Would that work? Okay, we'll all do it together. I'll give you like 5 minutes. I'll take 5 minutes to do this because I didn't have time to prepare the lecture, so I don't have anything longer prepared, all right? Okay, so let me bring the next example to you and then we will do it together. Where are the professors? Good. In this one we have a picture also. I'll just do it like this. Just give me a second. I'll do it the easy way, okay? Everybody fine? So we will give each other what? 5 minutes to do this one and then we are going to compare answers. Sounds like a fair deal? All right, good. So, okay. Ready to do it together? Okay. So yeah, who is going to help me? Anybody? Okay. All right. Elf is not helping because that's all right. Okay. Okay, Leah, would you help, please? Okay. So here we have what? We know, see, this is x, right? That's what he gave us. And he is telling us that it's moving away at what rate? 1 feet per second, right? Makes sense? So, and then he wants what? That how would this h slide down, right? Everybody fine? Okay. And so we will have, somebody tell me the relationship that we will have, and we are, yeah, he wrote there's a vertical wall. So this angle is what? It's a right angle, right? Everybody good? Okay. So how would you relate x with h so that we can relate their rates of changes quickly? Yes, go ahead.
Pythagorean theorem, so 13 squared minus.
Oh, so I'm sorry. Yeah, 13 is square.
Minus the 5, you have that point, x, 5 squared.
That will be when h is 12. You're absolutely right, right? But since we're going to do it for the rates of change, let's just get the relationship between the variables exactly the way you wanted, all right? Or the way you suggested, and then we would differentiate, okay? Very nice, very good. Okay, it's very encouraging class, huh? So we have x square plus what? H square equals what? 13, right? Oh, 13 is square. Very good. Yes, I told you I'm depending on you. All right. So we would do what? Differentiate with respect to, again, we are assuming that both of them are functions of time t, right? Okay. So when we did that, okay, then in that case, too, would you help me differentiate it, please? I have x square plus h square equals 13 square, right? Okay, so yeah, go ahead and differentiate it for us, please. Just say that once again. Not yet. 2x. Very good. Yeah, that's very helpful. Thank you, though. Okay. 2. Oh, yes. See, I forgot my h. Good. 2h. Great. Equals 0, of course, because that's what? Okay, makes sense? Very nice, okay? So, now these 2's will cancel, wouldn't they, right? Okay, and what we are going to do is, now if you solve for dh over dt, because that's what our objective is, right? Okay, makes sense? Then what are we going to get? And I can show you the details of this algebra if you want me to. Very gladly I'll do that for you. Okay, but, okay, all right. So this is what, is everybody comfortable with that? Everybody, yes, go ahead.
How do you get rid of the 2's?
2's, see, I just divide the equation by 2, all right? So 2 is a non-zero number, so, 2 cancels this 2 and this 2, and 0 divided by 2 will be 0, right? Very good. Thanks for asking it, okay? Everybody fine? Now, we know this. We know that dx dt, what did he give it? Louder? I think, yeah, he gave us a number. 1 feet per second, right? Okay, so it's 1 feet per second, right? And what does he want us to find then? He wants us to compute dH dt, right? At the instant he gave us, what's that? X equals how many? 5. Very good. Now, one thing is there. We want it at x equals 5. Would somebody tell me? Actually, you told me before that when x is 5, h is how much at that time? X, yeah, right. H is going to be 12, right? Okay. Am I just talking to this monitor here, or everybody? Yeah, go ahead, please.
So after you got rid of the 2's, then how do you got the X?
Okay, I see.
X or H?
Yeah, nothing, I'm just being lazy, okay? All right, and don't let me get away with that, all right? Okay, so here. See this here? Oh, you said you were fine with this, right?
Yeah.
Makes sense? Okay, then see what I did was this, that I am trying to solve for dH dt because that's what my objective is, right? So I am subtracting this quantity from both the sides. Is that acceptable?
Yeah.
Okay, and then what I would do, I still don't have it isolated, so I'll divide by h, okay? And you asked a very good question, okay? So we have to do this, that we have to have this, that the ladder is not really, flat on the ground. So I think that question had a good payoff, okay?
His question is dx dt, is that no? Let me see.
Say that again. Yeah, I'll let you see everything. Yeah, go ahead. What his question is?
dh over dx or dx over dx?
Oh, what did I mess up? Go. Sorry, Jeremiah.
dt will be constant with dt.
No, dx over dt is constant. Okay.
Then dh over dx will be, or dx over dh.
Oh, you want say that once again?
dh over dx or vice versa, dx over dh.
Okay.
When dt cancelled by dt.
Okay. One sec. Okay. Oh, why would you cancel anything here? We worked so hard to get all these quantities, right, Jeremiah? Right? It was a very good question.
What I mean is that when you, this according to the sequence.
Okay, just a second. We are together this far, right?
Yeah.
Okay. All right. Are we good here or no? We are good here, right? No. Now, we are not good here?
Well, it wouldn't it be like negative x dx over dt over h? Isn't it h? Like,
Okay, just a second. I'm doing this dividing by h, assuming h is not 0, right? Okay, so let's see. So here I'm going to get h over h, right? Makes sense?
yeah.
And, well, I could divide it only by one factor, right? And then here I have x over h. All right, and now after this we are having some communication gap, all right? Okay, all right, Jeremiah, you said this is good, right? Okay, what about, this is good as well, you said, right? Okay, everybody fine on this so far? Okay, all right. So then, yeah, what's the question, Jeremiah? Tell me.
I got you.
It makes sense? Okay, very good. I did this. It was my fault. I skipped these steps, so I paid for it, didn't I, right? And the thing is this, and this question clarified one thing, that is, it's okay. So everybody good? And yeah, I am like this. I skip steps. That's a bad habit that I have. Okay, but just keep. Now, which of these values you want me to choose? Which one in this context? H equals? See, when x is 5, right, we have to write what h is because we have to put that value in as well, right? Okay, so h is how much then? 12, and this 12 feet we meant here, right? Okay, good. All right, so, and so this is the same as, say, we wanted to write it in terms of what this will be in terms of h. Okay, so what should I change this to? H equals 12, right? Okay, good, very good. So what this will be then, this quantity, if I wanted it, this quantity is louder. 5, very nice. 5 over 12. I'm taking longer to write it. Then you can, so this is 12, and this guy is simply what? It is a 1. I'm just writing it a 1 just for sake of formality. All right. So this is negative 5 over 12 feet per second. Okay. And why do we have a negative sign here? Would somebody help me with that? Is going down, so h is decreasing, right? Okay, makes sense. So then after this, okay, any questions anywhere? I have the whole transcript is still sitting here for you. Anybody? Any questions? No questions? Okay, all right. Nasir, any questions for me, sir? It's good, very good. Good to have certification. So this is what you all are working on, right? Okay, everybody fine? And now I'm going to take your help to do this. So in here, what we have, a water tank has the shape of an inverted circular cone with base radius 2 meters, and I think he means clearly that it's a right circular cone. Okay, everybody fine? Okay, and its height is how much? 4 meters, and this is 2 meters. And this is the rate at which the water is being pumped into the cone. All right, we can make fancy pictures of, pumping in, but let's not do that, okay? So first thing we need is what? A formula for the volume of the cone, right? Okay, would somebody remind me of the formula? I don't know who knows. Well, somebody knew the formula, I think. Yeah, who is helping me with the formula? Anybody?
1/3 pi r squared times the height.
Very good. And yeah, you had told me and I had it memorized. See this here? Good. So this is what we got, right? Everybody clear? Oh, I'm missing the pi. I didn't have it memorized well. Okay, I'm missing the pi. Let me get the pi. Okay, and now my whole drama is compromised here, isn't it, right? Okay. Everybody good? Oops, did it go? Right here. Okay, makes sense? Good. Okay. So,
Your video is off.
oh, what happened?
I thought it was off.
Okay, this guy is off. We'll fix it. Okay, it's fixed. Okay, good. Okay, where are we? Right here. Okay, so what is this quantity in terms of these symbols? Somebody? Anybody? Alex, would you help us? This dVdt. Very good. And we need what? dHdt, right? Everybody clear? So here. So we know this. Yeah, the media is off. Let me fix the media here. Okay, come on, media. Right here. Okay. And we go down this far. Okay. So we are going to do dVdt, and we can use the product rule if we would like, right? Okay, if we would like, okay? But then we would be having dV over dt, dr over dt, dH over dt, and we don't know how to, work that far. So any solutions here in the middle, like R and H, okay? We got two variables here, right? So yeah, would somebody tell me how to get around that? Like what should we do so that, anybody? Yeah, go ahead.
We just plug in 3 meters and height.
Okay, I see. We will have to do that, yes. Okay, very good. We will use the 3 meters eventually when we want to find the value of H. Yeah, that's very good, Stephen. Very nice, okay? But can you give me a relationship between R and H? Okay? I think I saw Chen doing that. Chen, would you help us? R is 1/2 H. Why is Chen saying that? Because notice this. I mean, this triangle here and this one here are similar triangles, right? Everybody clear? So we know this, that this altitude or depth is what? Twice the radius, right? Isn't it? Everybody clear? That's twice the radius, or the height is half the radius, because we have to get dh over dt, so we will go in Chance's style. That's much better. Okay, so what we have is r is h divided by 2. Everybody in the room comfortable with that? Is everybody? Make sense? Okay. All right, so we all agree. So we know this. What do we know? Know that this is, what was that, 2 meters cubed per second? Am I? Yeah, okay, thank you. Thanks for, okay, all right. So here we go. We know that, right? Okay. And we also agreed that we saw from that picture that R is what? H over 2. Everybody good? R is H over 2. So what we can do is this, before we proceed, why don't we just convert it to this? Where are we? Here we got H over 2, right? Okay, and then we just have to expand it, right? So what we got then is, again, see, I'm skipping steps. I know it's a bad habit, but does anybody have any questions on this? Okay, and I know many of you have done it, so those of you who have done it already, are we going the same so far? Okay, if we have the same approach. Okay, William, make sense so far? Okay, good. Philip? Okay, good. So now we are ready to differentiate, right? So let's do this here. We got dv dt. Oops, not that. Okay, and then I'm just going to keep pi over 12 outside. That's a constant. Okay, so then we got what? D dt, and then I have h cubed here, right? Everybody clear? And I don't. Okay, so d dt h cube, what that will be? Somebody? 3h square dh dt. Anybody any questions on that? Because I think we are using Chen too much on just this one question. So okay, good. And then we can simplify it. Okay, and here we go. What does it? 3 times, very good, pi h square over 4, right? Okay, so pi h square. First of all, before I go ahead, is everybody fine? Everybody? All right, Jeremiah, am I making sense, sir? Whole thing good? Okay, all right, I'm seeing. Okay, so that I told you, I got a good class to sub in. Okay, so now we have to obtain dH over dt at the instant water is how much? 3 meters deep, right? Okay, all right. So what we will do then is water is 3 meters deep. So tell me this, when R is 3, at that particular moment, what H will be? Help? Somebody? Say that again?
Isn't the problem that H was 3?
Oh, is it? I'm so sorry. Oh, okay, I'm not reading the prior. You're absolutely right. I was making something simple too complicated, right? Thank you. Okay, so this is bad. All right, officially, let me take it out. Yes. So H equals 3 feet, okay? All right, at this place, right? So good. So we have to obtain what? We have to obtain the value of this rate of change, right? When H is, oops, what did I do? Did I do anything bad? Undo, I think I picked louder.
Metal or
I didn't hear you. Say that again?
unit? Metal or 3 metal?
Oh, I don't know. I have no idea what. Yeah, I'm doing this, and I promised I'll post it for you on the internet. So, and I'll still post it, even though it's not going to look very good on me. Of course, I'm changing meter to feet, I'm changing depth to radius, don't know where I'm going, which is not good. Okay, to find, but that's all right. Good. Everybody good? Okay. And I mean, I can take the excuse that I was just catching your attentions, okay? But no, it was just I was making a mistake. So this is what? Is this 2? Am I right? This is 2. This is what? What is this? 3. All right. Okay, and this guy is going to be what? This at actually, let me just put this one in here. Everybody fine? Okay. So what that will be, let me see if my head is still working right, because I didn't do too good on that. So that's going to be 8 over 9 pi. Am I right or wrong? Okay, all right, so good. So that's comforting. All right, 9 pi, and then what units are we measuring it? Meters or feet, or it's what? Meters, and per what? Second, right?
I think it's per minute.
Per minute. See, oh, it's still, that's not very good. Okay, but that's all right, per minute. Okay, makes sense? Good. Okay. Okay, so what we got here? There are 2 cars. Okay, one is traveling west and the other one is traveling north, right? Everybody clear? Okay, I don't know what will be clear. Okay, so say this is what? West, right? And am I right? If that's west, then this will be north. Did I do that right? Okay. And they are headed to what? This particular intersection. Okay, so both the cars are going to this intersection. Make sense? Okay, 1 sec. 1 second. Okay, right here. Okay, good. Now, at what rates are the cars approaching each other? Okay, what would he mean by that is, I think he means at what rate is the, yeah, somebody help me. I mean, you listen to him a lot more than I do, so help. Yeah. This is traveling west. Okay, first of all, I got my pictures wrong again, right? No? This is traveling west, and this guy is traveling what? North, right? So the whole picture is wrong. Am I right or wrong? I see. So I am right that I'm wrong, which is interesting, but that's what it is, right? Okay, come on. Okay, so this is west, right? So if they're approaching each other, right, I should have made it like this, right? Okay, so let me make it better. So one car is coming in from here and the other one is from this way. Is that looking correct? Okay, good. And I actually, I told you I didn't have time to prepare, so okay, so here we go. All right, so this one is traveling west, right? And this is traveling north, right? Makes sense? So the rate of change of this is 50 miles an hour, and the rate of change of this one is what? 60 miles an hour. And we have to find what? The rate of change of this distance. Am I right? Okay. All right. Anna, am I making sense? Okay. And all right. Everybody, am I making sense? Okay. Good. Okay. So this rate of, okay, so just so let's just do this. God bless you. All right. Okay. And this is of course a right angle because of the way the directions were given, right? Okay. So let's take this part as say x. Okay. This as what? Y, right? And this is going to be what? R, right? And at this time, he has given us the rates of changes of both the cars, okay? And then we have, can you note it down so that when I go to the other screen, then I don't have to recall the values again and again? So does anybody have it noted down? Okay. Or I can put two screens, but then we can't see very much, okay? Okay, so in this case, what you have is, you have this. You got x square. Okay, why am I saying, everybody clear on what I'm saying? X square plus y square is what? R squared, very good, right? Good. And we know that I think both the cars are under cruise control, right?
Yeah.
Okay, so one of them has what? dx dt is? How many? Let me go back. Yeah, this is is 50 miles per hour, right? Okay, so it's 50 mph, right? And who is my dy dt? Okay, okay, just a second. Yeah, I am messing up something. Say that again.
I think dx is the one going west.
Dx is the one going west, right? Yeah. So what did I write there? I did. That's not very good. No, I wrote 50. Okay. That's all right. Okay, okay. And we can put it like negative, right? Can't we? Because this is decreasing. And the other, this guy is what? Negative 60 miles per hour, right? Makes sense? Okay. And then, what's the next thing? We have to find out at what rate is R louder? Anybody else? Somebody made a remark or just heard something? Okay. So now in here, A is, and which one is A? This guy is A. I don't know why I didn't label it. Okay. This is A and this is what? This is my car, B, right? Okay. So they're saying at what rate are these guys changing when X is 0.3 and Y is how much? 0.4, okay? So at the instant when X is how much? 0.3, Y is how much? 0.4. First we have to find R at that particular moment, right? And again, yeah, we like recalled Pythagoras a lot today, right? So let's do that again. So square root of what? X square plus y square, and in this case, it would be what? Help. I have square root of 0.3 square, okay, then plus 0.4 square, and then what we get? Okay, 0. And of course, these are both in what? Miles, right? These are all in miles. Everybody clear? Okay, distances are in miles. Everybody good? Okay. So what will be our next step then? We'll differentiate, right? Okay, so when we differentiate, who is helping me this time? Anybody? Lily, will you please? I'm going to differentiate. So when I differentiate this equation with respect to t, right? So for x squared, what would I have? Just chain rule, 2x, right? Then go ahead, Lily. Okay, go ahead, Lily. Dx over dt, right? Okay, yeah. Then plus we have 2y, and then what? Louder? Yeah, that's an r square. Yes, you're right. Okay, and I think I messed up something. Was that? I should have changed it. Okay, and then this becomes what? As you correctly said, 2r dr dt now. And we want it all at what instant? See, when, okay, I know it's like classes. Okay, so at this time, yeah, what will we do? We have everything in here, so we just have to plug it in. All right, and after this, I think I just saw his question is becoming interesting. First of all, everybody fine if I just divided by 2, right? Makes sense? Okay. And then x is how much? 0.3, and dx dt is, what was that? Negative 50, am I right or not? Okay. Then plus y is how much? 0.4, dy dt is what? Negative 60. Thank you. Yeah, say it like that. I like it. Okay. Then we have what? 0.5, and then we have to get what? The rate of change of r, right? And I can put this right here, that it is at this particular instant, right? Okay, so we have this r is 0.5, right? So how much is this guy then? I mean, how much is this quantity? Okay, that's what I meant. That will be what? I'm going to just let the computer do the arithmetic for us, okay? All right, and what goes downstairs then? 0.5, and who this will be then? Negative 78 miles an hour, right? Yeah, is that correct? Okay. Are the units okay? All right. Those of you who are working ahead of us, do we have the same answers? Okay. Nasir, makes sense? So what happened? You got 76. It could be my fault as well, or I might have switched something around, or you might have. So let's see. We will check it out, all right? Okay, I don't think that I'm going to be fired because of a YouTube video, okay? So I think we should be. Hey, Dr. Judy. Okay, just 1 second. Yeah. Okay, Frank. Are you done, Frank, with this? No? Okay. Now everybody read it, right? That this is what we are trying to work on, and this picture looks a little scary to me. So I'm just going to make things simple. Just do it the way we want to do it, right? Okay. All right. So here what we have, here is this car B, right? And we know which direction is B moving. I mean, what can B? I mean, B doesn't have much of a choice but to move in which direction? Yeah, that direction that I just erased, right? Okay, so here B is moving that way, right? And then we got this. We will just make a, all right. So here, I mean, so here is my A, sorry, pardon the picture. Okay, so here we go. Everybody clear? And so what do they want? Okay, and then if we treat this as X, treat this as Y, then what do we know here? Help. See, the rope is how long? 39 feet, right? Everybody clear on this? Okay, and then Q is fixed, God bless you. All right, and then we have what? A is being pulled away from Q at 2 feet per second. So we have to find out what dy dt would be when this guy is like 5 feet from what? Q, right? Everybody good? Okay, so let's work on it. Let me see. I think that it might not be a bad idea to keep this picture here. Okay. All right. This way we have both these together, right? Okay, good. So excuse me. So what we have here, we got dx dt is what? Help? Just saw that here. Okay, that is 2 feet per second, right? Thank you. And where did that go? Where did my thing go? Okay, that's all right. I don't know. Write it again. dx dt is 2 feet per second, right? Okay. All right. and then this whole length is how much? 39, right? Okay, and then what do we have to find? We have to find d, what's that? dy dt at what instant when x is how far? Louder? 5, right? Okay, let me make sure. Yeah, 5 feet. Okay, so 5 feet. So it's like 5 feet from Q, right? Makes sense? So there's a lot to do. First of all, well, we have this as x and this is 12. So how would we relate x and y with each other? Once we have related that, then we are in good shape, right? Aren't we? Okay, so help me please. How do I do that? See, this is x, right? Is that good? So now x square plus 12 square is the square of this length, right? Am I good? And then you will have what? Y square plus 12 square is a square of this length, and the two total is how many? 39. All right, and don't think that I'm taking excuse of the clock. Okay, all right, so I'll just finish it, and when I post everything, I'll finish the whole thing for you, right? So in this way, what you would do, why am I talking? We still have little time, right? So let's see. Let's pretend that this guy is, say, no, sorry. Say this guy is, give me something for it, say R, right? Okay, then this will be who? What that will be? 39 minus R, right? Okay. So we have, so there is, and anything else given in here? 2 feet, and that is 5 feet from there, right? Okay, good. So you have what? X square. Anybody trying to catch my attention? I heard some knocking. No? Plus 12 square is what? R square. Very good. Okay. And then y square plus 12 square is who? 39 minus R square, right? Excuse me. Okay, 30. What did I do? No, here is y. I'm just getting a little nervous. Sorry about that. Okay, here. That's 39 minus R square. Everybody good on this? Right, okay. So now, and when x is 5, we can obtain R. I think that will be what? 13. If I'm doing it fast in my head, am I right? If this is 5, this is 12, that is 13, okay, at that instant. So I can get the value of y at that instant. How? I'll take 13 away from here and obtain y, right? Everybody clear? Okay. Now I'm talking too much, not writing much, so I will do this. Just go along these lines, finish it, all right? And then I'll finish it for you all.